Welcome back to the AI Academy's course on Python for data science. Today, we're going to dive deeper into the world of data visualization focused on the Seaborn library. Seaborn builds on the foundations laid by Matplotlib, which we explored in our last lecture. Remember those scatter plots, histograms, and bar plots we created? Today, we're going to expand our toolkit with even more types of visualizations using Seaborn. So, in our previous lecture, we got hands-on with the Matplotlib library, crafting basic plots that help in the analysis and interpretation of data. We covered the essentials of scatter plots, histograms, and bar plots, and discussed how to use Matplotlib to bring our data to life. In today's session, we'll introduce you to creating and interpreting advanced plots with Seaborn such as scatter plots, and we'll revisit these but with Seaborn's enhanced styling capabilities. Learn how Seaborn can add more polish and options to these plots. See how Seaborn makes these even easier and more visually appealing. Box and Whisker plots will be new. They are fantastic for showing distributions with quartiles and detecting outliers. Pairwise plots, perfect for exploring correlations and distributions between multiple variables simultaneously. We'll go through each plot type step by step, focusing not just on the how, but also the why, ensuring you know when and why to use each type of plot. So, get ready to enhance your visualization skills with Seaborn. By the end of today's lecture, you'll be equipped with a broader range of tools to tell compelling stories with your data. Let's dive in and start plotting. Let's start today's session by getting to know the Seaborn library. Seaborn is a powerful Python data visualization library built on top of Matplotlib. What sets it apart is its ability to create attractive and informative statistical graphs with a high-level interface, making it a favorite among data scientists for its ease of use and elegant output. Now, let's dive into using Seaborn by starting with one of the fundamental plots, the scatter plot. Seaborn simplifies the process of creating these plots while adding appealing enhancements that make them more insightful and visually appealing. Let's explore how to harness Seaborn for crafting enhanced scatter plots that not only look good but also convey a clearer understanding of the data. Let's gear up to dive into creating scatter plots with Seaborn by setting up our environment with the necessary Python libraries. Like in last lecture, we'll continue exploring data visualization by working with a specific dataset, the cars data frame. After and cleaning this data to ensure our visualizations are both meaningful and informative. As before we dive into visualization, it's essential to clean our data. Missing values can significantly impact the accuracy of our visual analyses. To ensure we're working with a complete dataset, we have removed any rows containing missing values. Let us now dive into creating a scatter plot using Seaborn, which will allow us to visually explore the relationship between the age and price of cars. This kind of plot is invaluable for spotting trends and patterns in the data at a glance. First, we'll set the aesthetic style of the plot. Seaborn allows us to apply different themes that can enhance the readability and appearance of our plots. For our scatter plot, we will use the dark grid theme, which provides a nice contrast and grid lines for easier interpretation of data points. As first step, we will import the Seaborn library as SNS and will set the theme as dark. So, now we will be creating the scatter plot using regplot function, which is specifically designed for plotting regression lines. This is perfect for our needs as it not only shows a scatter plot but also fits a regression model to the data. In this plot, age_converted is represented on the x-axis in years, and price on the y-axis, in dollars. The regplot function automatically includes a regression line, indicating the trend between these two variables. From the plot, you can observe that as the age of the cars increases, their price tends to decrease. This is a common-sense relationship, as older cars typically depreciate in value over time. The regression line in the plot gives us a clear indication of this trend. For example, a car aged around 5 is generally cheaper than cars that are newer. This line helps us quantify the decrease in price relative to the age and provides a visual summary of the trend across the dataset. Using Seaborn's regplot, we can not only visualize this relationship but also get a preliminary quantitative understanding of how one variable affects another. This plot is particularly useful for presentations or data analysis reports where you need to demonstrate or discuss trends in your data. If you prefer a simpler scatter plot without the regression line, Seaborn makes it easy to adjust. This can be useful when you're interested in purely observational data relationships without the analytical overlay of a regression model. So, to create a basic scatter plot in Seaborn without a regression line, we can modify the regplot function by setting the fit_reg parameter to false. This tells Seaborn not to calculate or display the regression line. If we discuss about plot details, it has solid round markers. These markers represent individual data points, allowing you to see the distribution and relationship between age and price at a glance. The x-axis is labeled age, and the y-axis is labeled price, which are automatically taken from the dataframe column names you pass to x and y in regplot. On the axes, you'll see values like 0, 1, 2, 3, etc. for age, and 5,000, 10,000, etc. for price. These are the tick labels that help you gauge the scale and intervals of the data being presented. The background grid remains visible, providing a reference framework that makes it easier to estimate the values of the scatter points relative to the axes. This scatter plot provides a clear and straightforward visualization of the relationship between the age and price of cars, free from any analytical interpretations that a regression line would imply. It's an excellent way to present data when you want your audience to focus solely on the raw data distributions or when discussing data points in a more descriptive manner. This approach is particularly useful during exploratory data analysis when you are first getting acquainted with the nature of the data. To customize the appearance of the markers in a scatter plot, you can change their shape using the marker argument in the regplot function. This customization can be particularly helpful when you want to emphasize different data points or simply enhance the aesthetic appeal of your plot. In this example, all scatter points are represented as stars, making the plot visually distinctive. Moving on to integrating categorical data with hue parameter in the lmplot function. This allows you to color code the data points based on the fuel type, adding depth to the analysis. To explain, this plot uses the hue parameter to differentiate data points based on the car's fuel type, enhancing our understanding of how fuel type might affect car prices relative to age. The Set1 palette from Seaborn is used to assign distinct colors to different fuel types, making it easy to differentiate between them at a glance. And the legends are automatically added to identify which color corresponds to which fuel type. This is crucial for interpreting the visual data correctly. The resulting plot displays the relationship between the age and price of cars, with color differentiation for diesel in red, blue for petrol, and CNG in green. This visualization helps in quickly identifying patterns related to fuel types without complicating the plot with a regression line. It allows stakeholders to easily see how different types of fuel relate to car pricing and age, providing insights that might influence decisions related to car sales, marketing strategies, or inventory management. Let's explore how to further refine these visualizations by adjusting marker transparency, shape, and size to convey additional layers of information. Scatter plots with advanced customizations like incorporating transparency, shape, and size. So, adjusting the transparency of markers can help in visualizing the density of data points, which is particularly useful when dealing with overlapping markers in densely populated plots. This can be controlled with the alpha parameter in Seaborn. And as previously discussed, changing the shape of markers can help distinguish between categories visually. You can use different shapes for different categories or even to represent different variables. And in the last, modifying the size of the markers based on a quantitative variable adds a layer of analysis, illustrating the magnitude of a secondary variable, like the engine size or horsepower of the cars. So, while interpreting the enhanced plot, The colors indicate different fuel types, making it easy to spot trends specific to petrol, diesel, or CNG vehicles. The traditional insight that older cars tend to be cheaper is visible here, but with added dimensions. By varying marker sizes according to engine size, you add another layer of data analysis without cluttering the visual. This helps in quickly assessing if larger engines, hence potentially more powerful or luxury cars, retain value differently compared to smaller ones. This allows for better visualization where data points overlap, making dense areas stand out and providing a sense of the distribution's depth. By using these visual techniques, you make the plot not just a simple graph but a compelling data story that provides insights at multiple levels. This method is invaluable for quick data assessment and makes presentations or reports much more informative and engaging. Let's dive into how you can use Seaborn to create a histogram, which is a powerful tool for visualizing the distribution of continuous variables such as the age of cars. This example will cover both the default behavior of Seaborn's histograms, which includes a kernel density estimate, KDE, and how to customize the histogram to better suit your analysis needs, including adjusting the number of bins. Let us now move on to creating a histogram with Seaborn. First we will look into the basic histogram plot. Seaborn's distplot, distribution plot, is the go-to function for creating histograms combined with a kernel density estimate, which helps in visualizing the distribution shape of the data. Here's how you can create this plot for the age variable from the cars_data dataset. This plot provides a histogram overlaid with a KDE curve, giving you a smooth estimate of the distribution. Next, we can also control the number of bins. To make your histogram more or less granular, you can control the number of bins. Fewer bins will give you a broader view of the distribution, while more bins will show finer details. In this plot, setting the bins to 5 simplifies the histogram, making it easier to interpret broad trends. For instance, the age range of 70 to 80 months shows a notably higher frequency, indicating that many of the cars are within this age range. Conversely, very new cars, 0 to 50 months, are less frequent in the dataset. These histograms allow us to quickly grasp the age distribution of cars in the dataset. We can see clear trends, such as the prevalence of older cars over newer ones, which might influence decisions related to inventory management or marketing strategies. By adjusting elements like the number of bins, you can tailor the histogram to highlight the aspects of the data that are most relevant to your specific analysis or presentation needs. This flexibility is one of the reasons why Seaborn is such a valuable tool for data visualization. Let's now explore how to visually represent the distribution of categorical data using bar plots in Seaborn, specifically looking at fuel types and their relation to transmission types, automatic or manual, in cars. So first we will look into basic bar plot. To visualize the frequency distribution of the fuel type in cars, you can use Seaborn's count plot, which is perfect for displaying the counts of observations in each categorical bin using bars. This plot will show the distribution of fuel types such as diesel, petrol, and CNG. It will clearly demonstrate that petrol cars dominate the dataset. Creating grouped bar plot, to add another dimension to the bar plot, such as distinguishing between automatic and manual transmissions, you can use the hue parameter. This allows us to differentiate between two categories within the same fuel type. So, the explanation of the grouped bar plot, the x-axis represents different fuel types, diesel, petrol, CNG. And the y-axis shows the count of cars within each fuel type category. The different colors represent gearbox types, with one color for manual and another for automatic, as indicated by the legend. So, we can see that the majority of cars are petrol-powered with manual gearboxes. The automatic transmissions are primarily found in petrol cars, with no automatic options observed in diesel or CNG cars in the dataset. This visual differentiation helps in understanding how gearbox preferences vary across different fuel types. Moving on to visual versus crosstab analysis, previously, we have used a crosstab to analyze these variables numerically. However, visualizing this data can provide a more immediate and impactful understanding of the distribution and relationships within the data. The grouped bar plot effectively showcases the dual influence of fuel type and gearbox type on the car population within the dataset, making it easier for viewers to grasp these relationships at a glance. By using these visualization techniques, you not only convey data more effectively but also enable more intuitive insights into categorical relationships within your dataset. Let's now look deeper into how to create and interpret a box and whisker plot using Seaborn, focusing on the price variable from your dataset. This type of plot is incredibly useful for statistical analyses, providing insights into the distribution, central tendency, variability, and potential outliers in the data. At first, we will create a box plot. The box plot, or box and whisker plot, visually represents the distribution of numerical data through its quartiles and often includes whiskers which can help indicate variability outside the upper and lower quartiles. Here's how you can create one for the price variable in Seaborn. This code snippet displays the price distribution vertically. If you prefer a horizontal box plot, you can switch the Y parameter to X. So, in this box plot, the lower whisker represents the minimum non-outlier value in the dataset, which is less than $5,000. This is the 25th percentile of the dataset. 25% of prices are $6,000 to $7,000. This line in the center of the box indicates the median price of the dataset. 50% of the prices, which is approximate $10,000. This is the 75th percentile. 75% of the prices, which is approximate $12,000 to $13,000. The upper whisker extends to 1.5 IQR above the third quartile and represents the maximum non-outlier value, which is approximate $16,000 to $17,000. The outliners are represented as individual points beyond the whiskers. They indicate extreme values that may need further investigation. The advantages of using box plots are like, box plots summarize a large amount of data in 5 simple statistics while also showing outliers. You can easily compare the distribution of prices across different categories, e.g., comparing box plots of prices by fuel type side by side. And quickly identify anomalies in your dataset, which can be crucial for data cleaning or specialized analysis. We can perform further customization in box plots in Seaborn by adding categories to color by, using the hue parameter, adjusting the aesthetics, or splitting your data into different facets for more granular analysis. This enhanced box plot provides an in-depth look at how car prices vary not only by fuel type but also by whether the car has an automatic or manual transmission, highlighting the multivariate capability of box plots. By using these techniques, you can leverage box and whisker plots to gain a robust understanding of the distribution characteristics of numerical data, making them an essential tool in your data visualization arsenal. You've set the stage perfectly for exploring how a box and whisker plot can be used to examine the relationship between a numerical variable, price, and a categorical variable, fuel type. This type of visualization is particularly useful for comparing distributions across different categories and identifying outliers or anomalies within those groups. Creating a grouped box and whisker plot, to visualize how car prices vary across different fuel types, we will create a box plot with fuel type as the categorical variable on the x-axis and price as the numerical variable on the y-axis. So, in the given plot we can see that x-axis represents different fuel types available in the dataset: diesel, petrol, and CNG. Each box represents the interquartile range of prices within that fuel type. The line within each box shows the median price for each fuel type. Observations like a higher median price for petrol can be immediately noted. These extend from the boxes to show the range of the data, excluding outliers. Points outside the whiskers are considered outliers and are plotted as individual points. These can indicate special cases or errors in data collection. The petrol cars tend to have higher median prices, suggesting they might be newer or more luxuriously equipped compared to diesel and CNG cars. The spread of prices in diesel cars is significant, showing both very low and very high prices, indicating a wide range of car types within this fuel category, from economical to premium models. The presence of outliers above the upper whisker for diesel and petrol suggests that there are a few cars significantly more expensive than most others, which could be luxury or high-performance models. This plot can tell stakeholders or analysts not just about average trends but about the range of prices within each category, which is crucial for setting expectations about market conditions or for tailoring sales strategies to different customer segments. By grouping the box plots by fuel type, you can effectively communicate how different categories of cars compare with each other regarding price, providing a clear visual representation of statistical data that can support strategic business decisions or further data analysis. Exploring the relationship between multiple variables using a grouped box and whisker plot can provide deeper insights into your data. In this case, you're analyzing how car prices vary not only by fuel type but also by whether the cars have an automatic or manual gearbox. This added dimension can help uncover more nuanced patterns in the data. Next, we will see about creating a grouped box and whisker plot with multiple categories. First, we will look into extending the box plot with an additional categorical variable. To include the gearbox type, automatic or manual, in your analysis along with fuel type, you can enhance the box plot by adding the hue parameter. This will differentiate the price distributions not only across fuel types but also across gearbox types within each fuel category. In this plot, the x-axis represents different fuel types. Different colors within each fuel type category represent gearbox types. In your setup, manual gearboxes are represented by different colors. The plot shows separate boxes for manual and automatic cars within each fuel type category. This allows for a direct visual comparison of how gearbox type affects car prices within each fuel category. You might notice that petrol cars have a significant price range, and perhaps automatic petrol cars tend to be more expensive than manual ones. It appears there are no automatic options available for diesel or CNG cars, which could be an interesting finding for market analysis or product development. Any outliers in the plot will be clearly visible, helping to identify exceptionally priced cars within each subgroup. The lack of automatic diesel and CNG cars could indicate a market gap or a deliberate choice based on consumer demand or manufacturing priorities. The difference in price ranges between automatic and manual versions of petrol cars could suggest different targeting strategies or customer preferences in the market. By using Seaborn's box plot with the hue parameter, you can effectively visualize complex relationships within your data, making it easier to draw meaningful conclusions and support decision-making processes with visual evidence. This kind of multivariate analysis is particularly useful in sectors like automotive sales and marketing, where understanding price dynamics across different vehicle attributes is key. Creating multiple plots within a single window, commonly referred to as subplots, is an excellent way to compare different aspects of the same dataset directly. In our case, displaying a box and whisker plot alongside a histogram for the same variable provides a comprehensive view of its distribution, central tendency, spread, and outliers. Let's walk through how to set up these subplots for the price variable in your dataset. Next, we will look into creating subplots in Matplotlib. So, to create subplots, you'll use Matplotlib's subplots function. This function allows you to define the layout and size ratio of the subplots. It includes creating a figure and a set of subplots with custom height ratios like box plot will be 0.15 and histogram will be 0.85. By plt.tight_layout syntax we adjust the layout to make sure there's no overlap. Next, we add the box plot to the first axis and the histogram to the second axis. After adding the plots, we will customize elements like labels, titles, or aspect ratios further. It's also a good practice to ensure the plots are clearly separated by adjusting the spacing between them. With space equals 0.4 we adjust the amount of height reserved for space between subplots. The box and whisker plot on top provides a succinct summary of the distribution, highlighting the median, quartiles, and outliers. This visualization is particularly useful for spotting outliers and understanding the spread and central tendency. And the histogram at bottom offers a more granular view of the distribution by showing the frequency of price intervals. It helps in understanding the skewness, presence of peaks, and overall range of the data. By combining these plots in a single window, you can quickly draw comprehensive insights, where we can easily compare the summary statistics from the box plot with the detailed distribution view from the histogram. Understand where the outliers lie in relation to the common data distribution. Simultaneously analyze different aspects of the same variable without switching between different plots or windows, making your data analysis workflow more efficient and integrated. This approach not only saves space but also enhances your data storytelling by allowing viewers to see multiple dimensions of the data at once. Whether you're preparing a presentation or conducting an exploratory data analysis, such joint visualizations can provide superior insights. Next, we will look into the pairwise plots, also known as scatterplot matrices, are a fantastic tool for exploring all possible relationships between multiple variables in a dataset simultaneously. In Seaborn, the pair plot function makes it easy to visualize these relationships by automatically creating a grid of axes such that each variable in your data will be shared across the y-axis across a single row and the x-axis across a single column. The diagonals offer a univariate distribution view of the variable, typically shown as histograms. To generate pairwise plots that illustrate both joint and univariate distributions and color the data points by another categorical variable such as fuel type, you can use the following approach. In the output, the diagonal plots are histograms for each variable, showing the distribution of each variable across the dataset. For instance, a plot where both x and y are price will show the distribution of price across all cars. The off-diagonal plots are scatter plots showing the relationship between two variables. For example, a plot with price on the y-axis and age on the x-axis will show how the price may decrease as the age of the car increases. Using hue equals fuel type differentiates the data points by fuel type, providing an additional layer of information. This can help in quickly identifying if certain characteristics are specific to certain fuel types. The benefits of pairwise plots are like comprehensive analysis, which allows for a quick, comprehensive overview of all possible relationships within a dataset. The correlation discovery helps in identifying potential correlations between variables that might not be immediately obvious. The outlier identification scatter plots can help spot outliers or unusual distributions of data that might warrant further investigation. The customization options like the kind controls the kind of plot to draw between variables on the off-diagonals. Default is scatter, but can be set to reg for regression plots. The diag_kind controls the kind of plot to draw on the diagonals. Default is auto, which plots histograms for numerical variables and bar plots for categorical variables. The palette option allows customization of the color palette for different levels of the hue variable. Pairwise plots provide a bird's-eye view of the relationships and distributions within your dataset, making them invaluable for initial exploratory data analysis. By using these plots, you can visually assess trends, patterns, and anomalies across multiple dimensions, thereby facilitating a deeper understanding of the data before moving on to more detailed analysis or modeling. As we conclude today's session on data visualization with Seaborn, let's take a moment to recap the valuable skills and techniques we've explored. This summary will help solidify your understanding and provide a quick reference for future projects. We learned how to create scatter plots to observe correlations, trends, and outliers between variables like price and age of cars. We used histograms to see how data points are distributed across different intervals, helping identify skews in data like car ages. Enhanced the simple bar plot by adding a secondary category, providing deeper insights into categorical relationships, such as how car features vary by fuel type and gearbox type. We visualized the distribution of prices, comparing different fuel types, and observed how automatic and manual gearbox types affect car prices. We created a matrix of plots that included both scatter plots for bivariate relationships and histograms for univariate distributions, color-coded by fuel type to enhance interpretability. Throughout this session, Seaborn has proven to be an incredibly powerful tool for data visualization, allowing us to create clear, informative, and attractive plots. These visualizations are not just charts, they are storytelling tools that provide insights into the data, guiding data-driven decision-making processes. Thank you for your attention and participation. We hope that you found this session informative and are now more comfortable using Seaborn to explore and interpret your data visually. Whether you're analyzing sales data, customer behavior, or any other kind of dataset, these tools will help you to uncover the underlying patterns and stories your data has to tell. Keep practicing, exploring, and visualizing. The more you use these tools, the more insights you can extract from your data, propelling your projects, reports, and analyses to new heights. In the next lecture we will see how to deal with missing data for both numerical and categorical variables. We hope that you have found this course informative and interesting. Please hit the like button and subscribe to our channel and stay tuned for upcoming courses. Your support means a lot and motivates us to create more educational resources for you. Thank you for watching and see you again in our next lecture.